Hello, everyone. Today's video is on implicit differentiation. So what we've been doing is we have y on one side and everything x and constants on the other side. And we would just take the derivatives using the rules that we've seen before. What if we cannot have y on one side and everything x on the other side? Okay. Then we call that implicit differentiation. We can still get the derivative as a function of x and as a function of y, all right? Maybe to do a slope of a tangent line or whatever else, but we can still do it. This is basically an extension or just a different application of the chain rule, right? It's nothing new. We've done it before. Let's see how we can do it again in this case. So for implicit differentiation, we'll use the same rules that we've used before, but mainly we'll be using the chain rule where y and u are the same in this case, because u is also a function of x here, and all of these were derived or were written in terms of the chain rule using u as a function of x. So let's go ahead and take the first example. Let's look at it, okay? So for this session, I just want to clarify that y is a function of x, and some people write derivatives as dy dx. Some people as y prime. We're going to use y prime just to make it less crowded, okay? But dy dx and y prime are interchangeable. And again, you should keep in the back of your mind that x is our independent variable, and we are doing dy dx when we are writing y prime. So here's the first example, okay? Let's look at it. Now, with a little bit of algebra, I can put y on one side and y and then x and everything x on the other side. But let's just do it using, again, implicit differentiation, which is the chain rule where y basically is a function of x. Okay? So let's look at the first term on the left. Here we see something to a power, some function of x to a power. So the derivative is the generalized power rule. So we have a 2 x squared plus y squared prime to the 1 power, right? We reduce the power by 1 times the derivative of that thing that was raised to the power, right? Equals, on the right side, I have sine of 3x squared, sine of a function of x. So the derivative is the cosine of 3x squared times the derivative of 3x. It's regular chain rule. Now let's go to the left again. 2 x squared plus y squared to the 1 power. Now I take the derivative of x squared plus y squared. The derivative of x squared is 2x. That's simple, plus derivative of y squared. Remember now, y is a function of x. Think of it as u. So we need to use also the power rule. So we drop the power, y to 1 less power times the derivative of y prime. And on the right-hand side, we have cosine 3x squared. The derivative of 3x squared here is 6x, right? Just a regular power. So now we're going to solve for y prime. Again, find y prime. So let's divide by 2x squared plus y squared. Get rid of this. So we'll have 2x plus 2y prime. Y to the first power, or just y, times y prime equals 6x cosine 3x squared over 2x squared plus y squared. Now the 6 and the 2 cancel out, leaving me with a 3 on top. And then I bring this over right there. Okay, so I'll have 2y, y prime equals, again, the 6 and the 2 leaves me with the 3 on top. So I'll have 3x cosine 3x squared. And I brought the 2x over, so it became negative 2x. And now I just divide by y, 2y, to isolate y prime. So y prime is, let's maybe push it down a little bit. Or maybe one simplified version. So that will be 3x cosine 3x squared over 2y. And then I'll have minus x over y. I just divided each term here, right here, by 2y. You don't need to get a common denominator or anything like this. You can't hardly combine anything, but I mean, maybe the x can be factored out, but this is it. This is the idea, is now we have y prime as a function of x and y right here. We were able to do it, okay? As we'll see in the application section, when we compute slopes of tangent lines at a point, all we need is this, because the point is basically an x and a y. So we plug the x and a y in here, and now we have the slope of the tangent line without knowing the explicit function y of x. Okay? We don't know what the functional dependence is. All we know is that maybe it's not even a function, okay? But we don't need to know y as a function of x or y as a relationship with x. All we need is y prime. Let's work out another example. Let's look at this one. Now, this one is definitely, we cannot say y equals something of x over here and maybe constant. This is very, very difficult to do, but we can still get y prime. Let's go ahead and take, again, implicit differentiation for both sides. So basically, derivative of both sides. So the first term is this. Okay? So let's take the derivative of the tangent. And again, if you haven't memorized all these yet, the derivative of a tangent is the secant squared. Go to this table and refresh your mind with all these derivatives, okay? So we see a tangent of some function of x. Remember, y is a function of x. So the derivative is the secant squared of that function of x times the derivative of the function of x, the regular chain rule. Okay? Then minus, what do we have right here? We have here a product rule. Looks like there's a f and there's a g, right? Use the f, use the g. So from a couple of lectures back, a couple of videos back, we will use the product rule for this one. And the 3 comes along for the ride. So here it is. It's the derivative of the first times the second. I'll explicitly write it. Plus the derivative of the second times the first. Equals derivative of 5 on the other side is 0. So let's work on this side right here. Secant squared of x squared plus cosine y times. Now the derivative of x squared plus cosine y. The derivative of x squared is 2x plus cosine y. The derivative of the cosine is negative the sine. So it's negative the sine of y times the derivative of y, which is y prime. Okay? Minus 3 The derivative of y right here is just y prime plus the derivative of e to an x, to a function of x, is itself times the derivative of the power times the y that sits outside equals 0. There should be a parentheses like this. All right. So let's continue working on the first term. We can expand this out. So that will be 2x secant squared of x squared plus cosine y minus sine y times y. Oh, let's just put y prime first. Y prime sine y times secant squared of x squared plus cosine y minus. Now we can let the 3 in. Here's a 3 y prime e to the x y plus 3, and bring the y, put it in front of the e, times the derivative of x times y. Well, what's the derivative of x times y? Again, this is like an f and a g, two functions multiplied. So the derivative is the derivative of the first times the second plus the derivative of the second times the first. Okay? Let's leave things same way. Here a little bit. And then what's the derivative of x? Is 1 times y plus the derivative of y is y prime times x equals 0. Now we're done with calculus basic. It's just a matter of algebra right now to put y prime on one side, everything else on the other side. So let's see which term have y prime. Okay. This term has y prime. This one has y prime. And then when I multiply this with that, it will have y prime. Everything else, in other words, when I multiply this by that, will go to the other side, and this will also go to the other side. So let's take them to the other side. Let's put y prime on one side and everything else on the other side. So here's the first y prime. Minus 3y prime e to the xy. And then here, when I multiply this with that, I'll get a plus 3y prime xy e to the xy equals. This is going to the other side, so that's negative 2x secant squared x squared plus cosine y. And then when I multiply this with that, that will go on the other side, and I change its sign to a minus, so it'll be minus 3y squared e to the xy. All right, good. So now I can factor a y prime from every term. And what I can also do, multiply everything by minus. So we factor y prime on the left and multiply by negative sign throughout. So when I do so, I will have y prime times sine y secant squared x plus cosine y plus 3e to the xy. Remember, I multiplied everything by minus. So this becomes a plus, this becomes a plus, this becomes a minus, this becomes a plus, and that becomes a plus. Okay? So minus 3xy e to the xy, because I factor out a y prime, equals, on the left, I had 2x secant squared x squared plus cosine y plus 3y squared e to the xy. And now I can solve for y prime. Sine y, secant squared x plus cosine y. Oops. My algebra is not correct, so it'll be the right side. Plus 3y squared e to the xy over this. Okay? Doesn't look pretty, but I have y prime on one side and everything else on the other side. Again, if I'm given a point, I can easily get the slope of the tangent line, y prime, basically. All right? Here's another example. Maybe not as complicated, but still, we cannot separate this. We'll put y on one side, everything else on the other side. Implicit differentiation is in order. So we take the derivative, basically, on both sides. So let's do it. So here's the first term. What is its derivative with respect to x? Again, this is 3x squared, the regular power rule. Minus, now I'm taking the derivative of this. Here's the f, here's the g, two things multiplied. They both are functions of x. So what is the derivative? The derivative is the derivative of the first. I want to explicitly put it, times the second, plus this derivative of the second times the first. Minus, now I'm here, derivative of y squared. Y is a function of x. So its derivative is the generalized power rule, 2y, y prime. Okay, equals, on the right side, that's a straight line with a slope of 1. So its derivative is 1. So I'm still want to solve for y prime, but I still have some derivatives to take as well. Maybe some of them will give me y prime. So let's go ahead and finish taking derivatives. 3x squared minus derivative of x is 1 times ln of y plus the derivative of the ln of a function of x. Okay, let's go back. Right here, the derivative of the ln of a function of x is the derivative of that function or the argument of the log over the argument itself. Okay? So it's very straightforward. Again, just because it's y, you should not sort of like panic. It's like, oh, what do I do? It's just y is a function of x, so it's derivative over itself. Minus 2y prime equals 1. There should be a parentheses and an x over here. There you go. So now we have 3x squared minus ln of y minus y prime over yx minus 2y prime is 1. Now we isolate y prime. Everything else goes on the other side. In other words, this and this go on the other side. And here we factor out a y prime. Okay? So let's factor out a negative y prime. So negative y prime, I have x over y minus 2y, plus 2y equals. Here's the 1. I bring in the 3x squared. I bring in the negative ln y becomes plus ln y. Okay? So I multiply everything by minus, which means flip the sign on every one here and flip this, and then divide by this. So y prime equals x over y plus 2y. And on top, I'll have 3x squared minus ln of y minus 1. You can simplify, maybe get a common denominator here, and then multiply y by everything, but this is not necessary. This is good, because right now, you have y prime on one side, everything else on the other side, and then you can go ahead and do whatever it is that you want to do with it, okay? All right, let's move on, maybe a couple more examples. Excuse me. So again, we have something similar right here. Find y prime. All right. Well, we have two terms. Take the derivative of each equals the derivative of this. So what's the derivative of x squared? It's 2x plus the derivative of y squared. Again, y is a function of x. So it'll be 2y, the generalized power rule, y prime, equals ln of x plus y. It's the ln of a function of x. So it is the derivative of the argument of the log over the argument itself. On the left, we have 2x plus 2y prime equals, what's the derivative of x plus y? It's the derivative of x, which is 1, plus the derivative of y, which is y prime, over x plus y. So remember now, I need to isolate the y prime, okay? And then bring everything else to one side. So we could do it in many ways, okay? We could separate these here right now and bring the y prime over, or bring the whole thing over. It doesn't really matter. It's all going to come out to be the same. So let me bring this over, okay? So 2x equals 1 plus y prime. Let me see if that works. Let's separate the right a little bit. So it'll be 2x plus 2y prime equals 1 over x plus y prime over x plus y. Okay. Now I can move y prime around. So let me bring this over this way and this over this way right here. So on the left, I have 2y prime, and I bring this from the right, so it's minus y prime over x plus y equals. I bring this over, so I have 1 over x plus y minus 2x. I factor out y prime on the left. Two y minus 1 over x plus y. And on the right, I can combine x plus y as a common denominator, and I'll have 1 minus 2x times x plus y. And I can do the same on the right now. I can also do this. We're going to assume x plus y is not 0. We can cancel them out. And then y prime equals 1 minus 2x times x plus y over 2y times x plus y minus 1. There is our derivative. Give me an x, give me a y, I can get the slope of the tangent line. I can take a second derivative. I could do a lot of things with it. All right. But again, it's very easy right now to compute things when I have y prime on one side, everything else on the other side. All right. We have a couple more. Let's go ahead and work out some more complicated ones. So again, here I have tangent of a function, the tangent squared of a function of x, and the ln of two things multiplied, then the cosine. So first, let's simplify a little bit. So this is tangent squared of x plus y minus, whenever I see the ln of a product, it's good to put the ln of the sum of each individual part. So this is the negative ln of x squared, negative the ln of sine of y, equals cosine pi x. Now be careful with this negative right here, okay? Because I have the negative ln of x squared sine y. This is like m, and this is like n, okay? So actually, let's take the negative. So we have ln of m times n. So it's ln of the first plus the ln of the second. So see, there's a plus right here. So when I have a minus in front of the ln, that means if I put a minus here, I got to put a minus here. And this multiplies this, and this multiplies that. So the minus gets distributed across each term. So now we have to have a minus in the middle. And now I can bring the 2 down. So this is tangent squared x plus y minus 2 ln of x minus ln of sine y equals cosine pi x. And now I take derivatives of both sides. So what do I see? The first term. This is the first term. What do I see? I see a tangent to a power, some function of x to a power. Automatically, that's the generalized power rule. I drop the power, tangent to one less power, okay, times the derivative of the tangent. Okay, just a generalized power rule with the tangent. Okay, f to the n prime n, f to the n minus 1 times f prime. Okay, f happens to be the tangent. Minus 2 ln of x, the derivative of the ln of x is 1 over x, minus the ln of sine of y, ln of a function of x. Sine of y is a function of x. So sine of y is a function of x. So it's the derivative of the argument. This is called ln of something. Oops. This is called the argument of the log. Sine, cosine, tangent, cotangent of something. This is called the argument of the sine. Okay? Same thing with the exponent. So it's the argument of the log prime over the argument itself. Cosine of a function of x. The derivative of the cosine is negative the sine of that function of x times the derivative of the function of x. Okay? Let's get back here to tangent x plus y times the derivative of tangent x plus y. Now we're taking derivative of a function of x. It's the secant squared of that function of x times the derivative of that function of x, the chain rule, minus 2 over x minus the derivative of the sine of y. Here's the derivative. Well, the derivative of the sine is the cosine times the derivative of the argument over the sine of y equals the derivative of the pi x is just pi. That's the slope of the line. So we put the pi in the beginning. There it is. All right. So we find a y prime first here, and then now we're going to get one from here. So let's continue taking derivatives here. So it'll be 2 tangent x plus y times the secant squared of x plus y times the derivative of x plus y. Derivative of x is 1. The derivative of y is y prime. Here's the negative 2x. Here's the negative. Cosine over sine is cotangent of y times y prime equal negative pi sine pi x. So let's isolate y prime. Definitely this is going to stay on this side. And when I multiply this with this, that's going to stay on this side. This is going to go to the right side. And I will multiply the 1 times this. That's also going to go to the right side. So I'll take those one by one. So here I have, was already there, minus sine pi x, pi x. I bring over the negative 2x, so it becomes 2x. Then I bring the 1 times these. Again, we're going to distribute this eventually, right? And then the 1 times that is not going to have a y prime. So plus minus 2 tangent x plus y secant squared x plus y. All right, so now we can factor out a y prime on one side. We'll have a 2 tangent x plus y secant squared x plus y minus cotangent y. That's this side right here. Okay. Equals, on this side, I have a 2 over x minus pi sine pi x minus 2 tangent x plus y secant squared x plus y. And now I divide both sides by this to isolate y prime. So here's y prime, 2 tangent x plus y secant squared x plus y minus cotangent y. And on top, I have 2 over x minus pi sine pi x minus 2 tangent x plus y secant squared x plus y. There is your derivative. There is your implicit, there's your y prime by implicit differentiation. All right, last problem. Again, a little bit involved, but that's good. That'll give you more practice. So let's do this. So what do we have on the first term? We see we have two things multiplied automatically, power rule. Doesn't matter what the two things that are multiplied, it's just product rule. Here we have e to some function of x. That's simple. And here we have, again, a simple function of x. So let's go ahead and take derivatives. So if this is my f, this is my g, I can easily take the derivative of that. So it's derivative of the first, the derivative of x is 1. I want to now skip the intermediate step. We're just going to go ahead and take derivatives. Here's 1 times the derivative of the sine of y, times sine y squared plus the derivative of sine y squared. Let me put that there because we're going to work on this. This is a little bit challenging. Times x minus, we're here now. The derivative of e to a function of x is itself times the derivative of the power or the argument. Plus 4x equals 2 stays there, the derivative of this minus the derivative of that. What's the derivative of x is 1 minus the derivative of a function of x is the derivative of the argument over the argument. Let's focus on this. Sine y squared. What's the derivative of the sine of anything? It's the cosine of that thing times the derivative of that thing. It's just a chain rule for the sine. Minus e to the xy. What's the derivative of x times y? Again, here, when I look at it, I see some function of x times another function of x. Product rule. derivative of the first times the second plus the derivative of the second times the first. Okay? Plus 4x. Sorry, the derivative of 4x is 4. I'm not sure why I left it there. Yeah. The derivative of 4x is 4 because, again, that's a straight line. The derivative is its slope. Here we have a 2 minus a 2y prime over y. So we're almost there. We can expand things here, but here let's go ahead and take the derivative of y squared. So here's my sine y squared. Now, cosine squared y times the derivative of y squared. Again, y is a function of x. Its derivative, we'll use it as a generalized function, generalized power rule. It's 2y prime. That's a derivative of y squared. Here minus y e to the x y minus y prime x e to the xy plus 4 equals 2 minus 2y prime over y. So how many terms have y prime in them? This one, and this one. I need them on one side so I can factor out the y prime. And then this term and this term need to go on the other side to combine with this term to basically, they don't have y prime. So let's do it. So here's 2y prime cosine y squared minus xy prime e to the xy. Here I have plus 2 y prime over y equals. There is the 2. I bring the 4 over, and I bring the negative sine y squared. Factor out of y prime. 2y cosine y squared. In the second term, I have an x e to the xy. In the third term, I have just a 2 over y equals 4 minus 2 minus 4 is negative 2 minus sine y squared. Okay. So I can divide everything by this right here. So I have a negative 2 minus sine y squared over 2y cosine y squared minus x e to the xy plus 2 over y. There it is. There is y as a function of x. Sorry, y prime as a function of x and y. Now we can do whatever we want to do with it, okay? But as you can see, it's just an extension of the chain rule. There's nothing mysterious about it. You just treat y like u in the beginning, okay? In the beginning, we identified, u as a function of x right here, and we worked with it. So this one is just the same, except it's called y, okay? On the next lecture, we'll be doing logarithmic differentiation, and we'll see how we use it. And then we'll go to applications where we take derivatives to find equations of tangent lines to graphs. Okay. Thank you for your time, and I hope to see you in the next video. Goodbye.